Hi, we are from Group 2 and now we're going to present to you a subtopic from application of differentiation, which is applied maximum and minimum value. What is applied maximum and minimum? The process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object. There are a few steps in solving maximum and minimum problems. The first step is find the derivative. The second step is let the derivative equal to 0 and find the values of the variables. And the last step is find second derivative test. Okay, now let's look at the question. The diagram shows a window in a shape of rectangular with semicircle on the top. The perimeter of the window is 8 meters. So the question asks us to find A. Express H in terms of x. B. Show that the area of the window is given by A is equals to 32x minus 4x squared minus pi x squared divided by 8. And C. Determine the maximum area of the window. Now, let's solve the problem.
The question given is the diagram shows a window in the shape of rectangular with semicircle on the top. The perimeter of the window is 8 meters. A. Express H in terms of x. So this is the diagram given. This is the x and this is the h, which represent the rectangular shape, and this is the semicircle. From the information we got from the question above is that perimeter is equal to x meters, so that's why we got here. And we also know the perimeter is the outer line of this diagram. So P is equal to x, this is x, plus 2h, h and h, plus pi x over 2, which represent the semicircle. P and P, the same thing, so we equate both of the equation here. A is equal to x plus 2h plus pi x over 2. To eliminate and cancel out the 2 right here, we need to times the equation with 2, and we got the answer is 4h is equal to 16 minus 2x minus pi x. So we know from the question is h is the subject, so we need to move 4 to here, when we got h is equal to 16 minus 2x minus pi x over 4. This is the final answer.
Okay, for the question B is show that the area of the window is given by A equals to 32x minus 4x squared minus pi x squared over 8. So as we know, the area of the window is a combination of area of rectangular and area of semicircle. So the formula of area of rectangular is x times h, and the area of semicircle is pi r squared over 2. So we can form an equation from that. So as we know, the value of h and the value of r in the previous question, so we can just substitute it into this formula, so we will get like this. After that, we have to expand until we get like this. So as we can see, the denominator for the both sides is not same, so what we can do is we have to multiply the numerator and the denominator at the left side with 2. So we will get like this. So as we can see, the denominator from the left side and the right side is same. We can simplify to get the final answer. So as we can see, our final answer is same as the question. So it means it's shown. So that's all from me. Thank you.
Question C. Determine the maximum area of the window. First, we need to find the maximum value. So, from question B, we can use the equation given to find the maximum value of x. The equation is a equals to 32x minus 4x power of 2 minus pi x power of 2 divided by 8. And we can simplify this equation and get a equals to 4x minus 1 over 2 x power of 2 minus 1 over 8 pi x power of 2. Then, we need to differentiate the equation. After differentiate the equation, we got the dA over dx is equal to 4 minus x minus 1 over 4 pi x. To find the maximum value of x, we need to do the dA over dx equals to 0. Then, we got the maximum value of x, which is x equal to 2.24 meter. And the third step, to determine the maximum value of x, we have to differentiate once again the value of dA over dx. This will get d square a over dx square equal to -1 over 4 pi, which is smaller than 0 for all x. This means it is a maximum point. So, the maximum area occur when x equal to 2.24 meter. From the first equation, we get a equals to 32x minus 4x power of 2 minus pi x power of 2 divided by 8. So, we have to insert the value of x in this equation. So, we get the area of the window is equal to 4.48 meter square.
In a conclusion, we can conclude that minimum and maximum problems can be solved by using second derivative tests. As examples given, all problems were solved surely using step-by-step that we chose until last step using second derivatives. Therefore, the first thing we should do is we must understand the requirements of the questions given. Then, we can find a formula or method that fits the questions given. Application applied maximum and minimum are widely used in real life. Many kinds of industry using this method to solve their problem, such as business platform to count their profit, either its maximum or minimum. Thank you for watching our video.